Welcome to Izika Academy YouTube channel. In this tutorial, I will examine set theory. If you are coming across my lecture for the first time, please like the video, share it with others, and subscribe so that you don't miss my upcoming videos. To my returning subscribers, I say thank you for being part of this channel. Set theory. What is a set? A set is a collection of well-defined objects, things, or units. The collection of a well-defined object is said to be set. The object could be a mathematical instrument such as the divider, the protractor, the compass, ruler, pencil, etc. That is the set of mathematical instruments. It could be a set of odd numbers. Odd numbers. Remember, odd numbers are numbers that cannot be divisible by 2, such as 3, 1, 3, 5, 7, etc. It could be a set of uneven numbers, such as 2, 4, 6, 8, 10, etc. It could be a set of natural numbers, numbers from 1 to infinity. It could be a set of English alphabet from A to Z. That is set. Set is a collection of a well-defined objects, things, or units. So we have representation of set. Representation of sets. Representation of sets. Number 1. Sets are usually represented in braces and not brackets. It is usually represented in braces and not brackets. Braces is like this, not like this. This is wrong. So we use braces for set. Number 2, the objects, sets are usually written in capital letters. Sets are usually written in capital letters. So if you have, let us say you have A. If A is set of odd numbers, you may have A equal to 1, 3, 5, 7, 9, 11, etc. So no, it is wrong to write it as A equals to 1, 3, 5, 7, 9, 11, etc. This is wrong. This is right. Why this is wrong? So we normally use capital letters for set. But don't confuse that with the element. Elements in sets are members of a set. The objects in set are called the element. Let me call that number 3. The objects in a set are called elements or member of a set. The objects, these are elements of this set, or the member of this set of an odd numbers, or set of English alphabet. So if set A equal to set of English alphabet, A, B, C, D, E, F to Z. So that is set A. A equal to this. So these are the elements of set A. Types of set. Types of set. Number 1 type of set I'm going to examine is finite set. Finite set. A set is finite where its elements or members can be counted. The element or member in that particular set where it can be counted, that set is said to be finite. For instance, if set A is a set of even number less than 10, even number less than 10, so you may have 2, 4, 6, 8, so and 8. These are even numbers less than 10. Then if set B is a set of set of English alphabet from A to Z, so you may have A, B, C, D, E, F to Z. That is set B. That is a finite set where its elements or members can be counted. I know we have 26 alphabets in English. So that is finite set. Number 2, we have infinite set. Infinite set, where the elements or members in a particular set cannot be counted. The elements in a set where it cannot be counted, e.g., if you have a set of English set of natural numbers. So if set A is a set of natural numbers, no natural number 1, 2, 3, 4 to infinity, you cannot count that. So such a set is said to be infinite. Number 3 is empty set or null set. Empty or null set. Empty set or null set. This is a set without element. A set without element or member at all. So for an empty set, you may have it as this. This is correct. It is wrong to write it as this. This have element 0. You may equally, this is wrong. Why this is correct? You may equally write it as this. So, empty set or null set is set without element or member. Number 4, we have universal set. Universal set. Universal set. From the word universe, entire world, universe. Universal set is a set that contains the totality of items under consideration. It contains the totality of every other set under consideration. All members or elements in every other set are contained in this single set. That is universal set. So, universal set may be written as like this or this for universal set. And if you want to represent this in the Venn diagram, it is the rectangle region. So we use rectangle, the region, that rectangle. We use it to denote the universal set. Take note of that. It contains the totality of every other set under consideration. Number 5, we have subset. Subset. Subset, if all elements of set A, are contained in another set B, therefore A is a subset of B. And the symbol for subset is this. This is pronounced subset. So if you have A, a subset of B, so it is written this way. So A is a subset of B. All elements of set A are contained in set B. So, for instance, if set A, if it is 1, 2, 3, 4, and set B equals to 1, let me say 4, 3, 2, 1. Then A is equal to B. This is an equality of a set. The two sets are equal. But for a subset, for you to say A is a subset of B, if set A equals to 1, 2, 3, 4, and set B equals to, let me say, 5, 4, 3, 2, 1. All elements of set A are member of set B. Therefore, A is a subset of B. So that is for a subset. Number 6, union of set. The union of set A and B is a single set that contains all elements of set A single set that contains all elements of set A or set B or both set A and B. Therefore, the number of set A union B, this is written as A union B. We said we say it is a single set that contains all elements of set A. All elements of set A are contained, or or is plus, or element in set B. Or both set A and B, or both set A and B minus number in element of A intersection B. This is and use it to denote intersection. So number in set A union B equal to number in element A plus number in element B minus the number in their intersection. I want you to take note of this formula. So I will still illustrate this. Then number 7, intersection of sets. Intersection of sets. Intersection of sets are the elements or members that are common to the given sets. Suppose you have set A to be a set of natural number from 1 to 10. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And set B are even numbers between 1 and 10. So we have 2, 4, 6, 8, or even a number less than 10. So if this is set B, so 2 is common to A and B, 4 is common, 6 is common, 8 is common. Therefore, intersection of set A and B, A intersection B, it is written like this. So we have it to be the elements that are common to both 2, 4, 6, and 8. That is their intersection. Then number 8, we have complement of sets. Complement of sets. Anything you have in universal set that are not in the set under consideration, that is said to be the complement of that set. So, complement of set A, it is written like this: A complement, A prime, or A complement. So you either write the complement of a set like this, either this or this. So, for instance, if you have the universal set to be numbers between 1 and 10, or let me say, suppose you have universal set to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, if you have it up to 12, and set A, you have it to be even numbers: 2, 4, 6, 8, 2, 4, 6, 8, 10, 12. So A complement now. Anything you have in universal set that are not in set A, that is said to be the complement of set A. That is, you have your universal set minus what you have in A. So that will give you the A complement. So you move the A, set A from the universal set now. So what do you have? So A complement will be, so we have 1 is there, 2 is common, 3 is not in A, 4 is there, 5 is not in A, 6 is there, 7 is not in A, 8 is there, 9 is not in A, 10 is there, 11 is not in A, 12 is there. So this is the complement of set A. Example 1. List the elements of each of the following sets. X, all numbers between 0 and 10. Y, all numbers less than 20. Z, even numbers between 9 and 31. Now let's have the solution. So X, we have X to be odd numbers between 0 and 10. Remember, odd numbers are numbers that cannot be divisible by 2. Numbers such as 1, since it is between 0. So we have 1, 2 is not there because 2 is divisible by 2. So we have 3, 5, 7 is an odd number, 9 between 0 and 10. So these are the odd numbers. Then Y, odd number less than 20. So we have 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. If it is prime numbers, 1 will not be there, 9 will not be there because 9 is divisible by 3. Prime numbers have no factors except 1 and itself. So 9 will not be there, 15 will not be there if it is prime numbers. Then we have Z. Set Z. Even numbers between 9 and 31. Even numbers are numbers that can be divisible by 2. So we have 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. That is even numbers between 9 and 31. So that is the solution to example 1. Example 2. Given that U equal to MATHISMUN, U is the universal set. So we have that to be MATHISMUN. Set A, we have the member to be M and A. Set B, we have THIS. Set C, we have IS. Set D, we have NUTS. You can see that all members of set A, B, C, and D are all contained in the universal set. You have to show that A union B prime or A union B complement equal to A complement intersection B complement. So to solve, you want to prove that this equal to this. So you will need, let's have the solution. You will need the union of set A and B. Union of set A and B. So all elements that are contained in set A or B or both. Elements in set A or set B or both are said to be the union of the two sets. Now, these are the elements in set A and these are the elements in set B. So elements in both, everything together, all together, are the union of the two sets. So we have MATHIS. M A, that is for set A. Set B, we have THIS. THIS. That is set B. But what we need is the complement of the union of set A and B. So we need A union B all in complement or prime. So anything you have in the complement will be the universal set minus A union B. So that is anything you have in the universal set that are not in the union of the two sets, union of A and B. So that is the A union B complement. So now let's check the universal set against the union of the two sets. You already have M is there, A is there, T is there, H is there, I is there, S is there. So the only thing you have that are not there, what you have in universal set that are not in the union of the two sets, are F, U, and N. Therefore, A union B prime, that will be F, U, and N. Then you also need A complement intersection B complement. So to solve for this, you will need the complement of set A separate, because it is only A that carries the prime here, and it is B that carries the prime, not both together. So you have A prime, anything universal set that are not in set A, that is set A minus universal set minus set A. So this is set A. You only have M and A in set A. M and A in set A. Anything you have in universal set, remove this from the universal set. If you remove this from universal set, then you'll be left with T, H, I, S, F, U, N. From here to here are in the universal set, but not in set A. So the A complement, that will be T, H, I, S, F, U, N. That is what you have in universal set that are not in set A. Then B complement as well will be universal set minus B, set B. So what do you have in set B? What do you have in universal set that are not in set B? So these are the elements of set B. M, A are not in universal set. Are universal set, not in set B. So we have M, A, then set B, we already have T, we have H, we have I, we have S. Then we also have F, U, N. F, U, N. So that is the complement of set B. And finally, you need A prime intersection B prime. A prime intersection B prime. That is what you need. That is what you have in A prime that are also in B prime. So M is not in both, A is not in both, T is not in both, H is not in both, I is not in both, S is not in both, we have F is in both, we have U in both, we have N in both. So we have F, U, and N. So that is the A prime intersection B prime. So if you now look at the solution here, so the A union B prime, we have that to be FUN, and A prime intersection B prime, we also have it to be FUN. They are both the same. They are both the same. Since they are both the same, so you may now write since A union B prime, A union B prime equals to FUN, and A prime intersection B prime is also FUN. They have the same member. Therefore, A union B prime equals to A prime intersection B prime. Proved. That is the solution to example 2. Example 3. In a market consisting of 50 traders, 25 sell either tubers of yam or onions. Tubers of yam is denoted by letter T, onion, letter Z, O. Of these, 4 sell both. There are 6 traders that sell onions. Find how many traders sell 1 tubers of yam, 2 tubers of yam but not onions, and 3 neither tubers of yam nor onions. Now let's have the solution to the question. In a market consisting of 50 traders, the total number of traders in that market are 50. That 50 represents the universal set. You may write your universal set like this or letter U. So, universal set, you have that to be 50. 25 sell either tubers of yam or onions, either T or O. That is union of the 2 sets. Number in T union O. We have that to be 25. 4 sells both. Both, that is intersection. Number of T intersection O. We have that to be 4. And 6 traders. Okay, there are 6 traders that sell onions. Number that sells O, that is onion. We have that to be 6. Find how many traders sells 1 tubers of yam. So the requirement 1, you have to find number that says T, tubers of yam. That is what to calculate in 1. Remember, I've told you earlier that if you have number in A union B, we said that could be number in A plus number in B minus number in A intersection B, which is the same as your A is T, while B is O. So that means the formula will appear as number in T union O equal to number in T plus number in O minus number in T intersection O. Their union, we have that to be 25. 25. The union of the 2 sets. The union of the 2 sets is 25. Number in T, that is what you have to calculate. Plus number in O, that is 6. Minus their intersection, T intersection O, that is 4. So solve for number in T. So make this the subject of the formula. If this is join 25, the plus become minus. You have 25 minus 6. If 4 joins them, you have the minus become plus. So number in T will be equal to 25 minus 6 plus 4. So 25 minus 6, that is 19. 19 plus 4, that is 23. Therefore, number in T equals to 23. So we have 23 sells tubers of yam. That is 23 sells tubers of yam. That is the answer to the A part of the question. Then 2, tubers of yam but not onion. Tubers of yam but not onion. That is referring to the number that says tubers of yam only. So tubers of yam, my figure 2. Number that says tubers of yam T only. So you will know that the number that says tubers of yam to be 23. So that will be number that says T. Since it is only, then you have to remove their intersection minus number or T intersection O. So number that says T, 23 as calculated. So we have 23 minus their intersection. The intersection of the 2, we have that to be 4 minus 4. So the answer will be 19. So that is tubers of yam but not onions. So we have that to be 19. Then 3, neither tubers of yam nor onion. Neither tubers of yam nor onion. So people that did not sell either of the two. So neither tubers of yam nor onion. So you have the universal set to be number that sell neither T nor O. That will be T union O complement, which is what you have in the universal set minus T union O. People that did not sell either of the two. So the universal set is 50 as given in the question, minus the union of the two sets is equally given to be 25. So 50 minus 25, so you have that to be 25. So 25 says neither tubers of yam nor onions. That is the solution to the example 3. So I will stop this video here. My next video, I will examine how to solve sets using a Venn diagram. Please don't forget to like the video. Also drop the love emoji. Thanks for watching Ezeka.